Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to be going over the combined gas law equation. So let's get into this. So in the previous video I was talking about the ideal gas law. So here's the ideal gas law. Remember, PV is equal to nRT or PIV-NERT. So if we rearrange this equation, we can get everything except for the R, the ideal gas law constant, onto one side. So if we divide both sides by n and t, we can get PV over NT is equal to R. So what this tells us is that these gas properties, when multiplied and divided together, should equal to the ideal gas law constant. So these relationships are constant to each other. And we saw this in my previous videos with regard to the relationships between the gas properties, right? So if I double the temperature, then my pressure should double, my volume should double as well, because the temperature is directly proportional to volume and to pressure. And volume is inversely proportional to the pressure, and temperature is inversely proportional to the amount of gas, and so on. So these four properties are related to each other by the ideal gas law constant. So we can see this in this way here. So if I have a set of conditions, right? So let's say I started with one set of conditions. So I have a certain pressure, a certain volume, and that's going to be equal to a certain amount of the gas multiplied by the ideal gas law constant multiplied by a certain temperature. So I've got my one set of conditions. If I rearrange this, then these set of conditions, the pressure, the volume, the amount of gas, and the temperature, that should be equal to R. So here I have an initial set of conditions. So here's my initial pressure, volume, amount of gas, and temperature. And that should equal R. So when I multiply and divide these, I get R. So now, what happens if I change all of the properties? I change the conditions. So I change the pressure, I change the volume, I change the amount of gas, and I change the temperature. Of course, R doesn't change. So then when I rearrange this, I get P2 times V2 over N2 times T2. So this new set of conditions is also equal to R, right? So I start at one set of conditions that's equal to R. I have a new set of conditions that's also going to be equal to R. So this multiplied and divided together should also give me R, right? Remember that these pressure, volume, temperature, and the amount of gas are all related to each other. If I change one, I change all of the others, right? So how I change them are going to affect the others in such a way that when I set this up, when I multiply pressure times volume divided by the amount of gas divided by the temperature, all in the right units, I get the R constant back. This is great because if I know that P1V1 over N1T1 is equal to R, and I know that P2V2 over N2T2 is also equal to R, then by logic, these two must be equal to each other. So P1V1 over N1T1 is equal to P2V2 over N2T2. And this, ladies and gentlemen, is the equation for the combined gas law. So the combined gas law equation is this. So let me write that down here. Equation. So this is the combined gas law equation. This is very, very useful for those problems that involve changes. So remember, this, ladies and gentlemen, this is the ideal gas law equation. So this is used for when there are no changes going on. Okay, you've got to remember that. So if you've got a problem that involves no changes, it's just, hey, here's a set of conditions, find the missing condition. Then the ideal gas law equation is the one you want to use. But if there are changes going on, so here's no changes going on. Let me highlight that. No changes. However, if you do have a problem where there are changes going on, like you're changing the pressure, or you're changing the volume or the amount of gas or the temperature, then the combined gas law is the equation you want to use. This is the equation you want to use. Now let me show you how fascinating this equation is and how useful this equation is. This, ladies and gentlemen, is the only equation you need to remember. Every other equation in law comes from this one, okay? Boyle's law, Charles' law, Gay-Lussac's law, Avogadro's law, all of those are hidden in here. So let me show you. Let me rewrite the equation so that way I can use it. P1 V1 over T1 N1. And it doesn't matter if you switch these, is equal to P1 V1 over T2 N2. Okay, so it's going to be really important when you have a problem that is involving changes in the properties of a gas, going from one set to another, pay attention to what is held constant. If in the problem it tells you that something is held constant, or if it's not mentioned at all in the problem, then you can assume it's constant. In the case that it's constant, remove it from the ideal gas law equation. Whatever's left after remove it is the equation you're going to use to solve the problem. So for example, let's say that I'm given a problem. They give me an initial pressure and an initial volume. But they tell me that the temperature is constant and they don't mention anything about the amount of the gas. So in that case, since they don't tell me what the amount of gas is, they don't mention the gas at all as far as the amount is concerned, then I can eliminate that from the equation. Since they told me that temperature is constant, I can also eliminate that from the equation. Anything that is not mentioned or that is said to be constant is eliminated. So in this case, what's left? I have this left. P1 V1 is equal to that should be a 2. These should be 2s, not 1s. 2s. So P1 V1 is equal to P2 V2. This is Boyle's law. So Boyle's law. And you don't even need to know that this is Boyle's law to use it. All you need to know is that P1 V1 equals P2 V2, and these are constant, so you ignore them. So this, ladies and gentlemen, would be the equation you would use to solve that problem. Okay? What about, let me go back. So if I have P1 V1 over T1 N1 is equal to P2 V2 over T2 N2. So now, what if I have a problem that says, okay, so your volume changes and your temperature changes, but your pressure stays the same, it's constant, and you're told that the amount of gas is constant, right? So in that case, I would eliminate the pressure because the pressure is held constant. So that gets eliminated. P1 and P2 get eliminated from the equation. And I'm told, or maybe even the amount of gas isn't mentioned, or I'm told that it's constant. In either way, I can eliminate it from the equation. And so in this case, I have what's left over for the equation is V1 over T1 is equal to V2 over T2. So now I have that equation that I can use to solve the problem. So in this case, maybe I start with an initial volume and an initial temperature, and they change the temperature on me. Maybe I have another temperature. They increase the temperature or they decrease the temperature. Whatever the case may be, I have a second temperature, but I need to find the volume of that new temperature. So what's the new volume of the gas at that new temperature? I use this equation to solve, and I solve for V2. I plug everything in, and I solve for V2, right? I don't even need to know what the name of this law is or what law this equation is tied to. I now know I can use this equation. I just plug all the information in, and I solve the equation, okay? And so that, ladies and gentlemen, is how you use the combined gas law equation. So, and the other great thing about this is you don't have to worry about making sure that your units are in liters. Volume doesn't have to be in liters, right? Pressure doesn't have to be in atmospheres or kilopascals. The amount of gas, that could be in moles, right? Or maybe even mass, but probably moles would be better. The only one you have to really make sure is the temperature. The temperature has to be in Kelvin. There's no ifs, ands, or buts about that. There's no exceptions. Temperature has to be in Kelvin for this to work. So anytime you're using this, and also the ideal gas law, of course, temperature is in Kelvin. So temperature's in Kelvin here, and temperature's in Kelvin here. So that's the only one you have to remember. So, and you probably want your gas to be in moles. If they don't give you moles, you probably want to convert that to moles. But pressure and volume can be in whatever unit they give you. Just make sure that both pressures they give you are in the same units. If they're not in the same units, then you got to convert them into the same unit. Okay, same thing for volume. If this volume is given in liters and this volume is given in milliliters, you got to change them either to both milliliters or liters. So that's the only thing you need to worry about. And so that's the combined gas law equation. I think that's all I wanted to cover with regard to the combined gas law. So this is a very useful law. So remember to use this one if there's a change. If there's a change going on in the problem, change in your properties, change in volume, a change in temperature, or something like that, you're going to use the combined gas law equation. If there is no change in the problem, if they're not changing temperature or volume or pressure or the amount of gas, then this is the equation you want to use, the ideal gas law equation. Okay, so that's it for this video. I hope you enjoyed this video. If you learned from this video, if this was helpful in any way, then please like the video, share the video, hit that like button, subscribe to my channel, hit that notification bell, and when you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, or if you have a problem or a question that you need help with, put that down below. I would love to help you with that. Thanks for joining me, and have a great day.